polynomial equations. This is solving those. Page 351 if you're not already there. So we already know how to factor out equations. So I'm going to write one down real quick and show you what it looks like factored. So it's 3x squared plus 6x minus 4. Now, we know how to factor this. When they have an equal sign, we can solve these, but they have to equal 0. They have to be equal to 0. This is a must. If it is not equal to 0, we cannot solve them. Okay, so make them equal to 0. The factoring of this is, well, let's just do it. Let's use the AC method. So AC is negative 12. I need factors of 12 that when subtracted will give me 6. Factors of 12 that when subtracted give me 6. Is there one? Of course not. Of course I would make one that's unfactorable. It's prime. So we got 12. Let me just double check, make sure. 6 and 2, 4 and 3. That's it, right? Son of a gun. All right, let's make one that actually works. So let's. Okay. Let's just go into an example. There's a zero product property. We talked about it when we were in Algebra 2. It's when something gets multiplied by 0, it is always equal to 0. So when something is equal to 0, we know that one of its multiples must be then equal to 0. So if they gave us the equation, like say this quadratic right here, x squared plus 2x minus 15. Okay, and they say it equals 0. First of all, we need to factor it. So if we factor this, we're going to set up two sets of parentheses. If we use the AC method, it's going to be negative 15. I'm going to say what are multiples of negative 15 that would give me, when found the difference of, give me 2. So 5 and 3, right? Which one of these is going to be negative, remembering that our middle is positive? Which one of these is going to be negative? The 3, because I need a positive up top, right? And in the middle. So I start with, what are factors of A? Factors of A, which is just 1, are obviously 1 and 1. So x and x are my only options there. Okay. Looking back here, I'm going to have different signs. So I'm going to put a plus, I'm going to put a minus. And then I just ask myself, how do I change an x to a 5x? Well, I multiply by 5. How do I change an x to a negative 3x? I multiply that by negative 3. Okay, so I have my two terms. Or let me rephrase my technology. My two factors. Okay, these aren't terms, they're factors. So I have x plus 5 and x minus 3. Zero product property says anything multiplied by 0 is 0. So one of these two factors must then be equal to 0. So we just set them both equal to 0. And you guys already knew this from Algebra 2. Okay? And you already know the shortcut, because you can do these in your head at this point. X must be negative 5, or x could be 3. And it could be both of them. I don't know. Okay? Either way, these would be my two solutions. Okay? These would be my two solutions. So, in other words, when you get to further points in this, these will be called your, bless you, x-intercepts. Okay? These are your intercepts, your x-intercepts. Okay? The coordinates of your x-intercepts on a parabola will look like, for this one, it would look like this. Okay, so they would have crossed here and here. So if I was going to write down these coordinates, it would be negative 5 comma 0 and 3 comma 0, because it's an x-intercept, it's where y equals 0. So you'll need this later on, so that's why I'm identifying it now. Okay, any questions there? That should just be a review. Questions, questions, questions? All right, where this gets a little different, let me just do one more just to make sure that we hit the nail on the head with it. 3x squared plus 2x plus 12 equals negative 13x. Okay, I want to solve this. In order to solve this, because it has an equal sign, okay, I can't solve anything unless it has an equal sign. In order to solve this, I need this to be equal to 0. I'm going to do that by getting rid of everything on the shortest side, pretty much. So I'm going to add 13x. I can only add 13x to its like term, 2x. Okay, so I get 0 on this side. I'm just going to drag down my 12 real quick. 13 and 2 make 15. And I'm going to drag down my 3x squared. Then I need to factor that if I can. So I'm going to use AC method. I get 36. Factors of 36 that when added together give me 15, 12, and 3. Right? So I set up my 2 parentheses. It's still equal to 0. And am I going to have same sign or different sign? Same sign sum. So I'm going to have to use which sign? Plus or minus? Plus, because the middle is positive, right? All right. Looking at A. A is 3. Since 3 is prime, this makes my life really easy. I have 3x and 1x. Okay. Now I ask myself, can I turn a 3 to a 12? Sure I can. Can I turn a 3 to a 3? Sure I can. Now we should notice right here that I have a problem. If my 3 can turn into both of these, what could I have probably factored out in the beginning? A 3. So maybe I should have factored first. Okay, so I'm going to go back and I'm going to rewrite this with a 3 factored out. So 3, open parentheses, and I get x squared plus 5x plus 4. This makes my life just a little easier, I guess. I'm still going to use my same set of parentheses, so I'm just going to erase what I don't need now. It's a little out of order, but if I notice that my 3 can change into both things, chances are I could have made my life easier at the beginning. Okay? I've seen a lot of you make that mistake as well, so at least you know how to recognize it. Alright. I need factors of 4 that when added together give me 5. What are they? 1 and 4, right? So 1 and 4, x. So my front term is x, so I know that my front term has to be x and x. Still same sign sum, so I have x turns into an x, I multiply that by 1, x turns into a 4, I multiply that by 4, and there is my factored out piece. I have to solve this because it says equal to 0. Okay? So I'm going to pull out each of my factors. Remember that 3 is a factor, but it doesn't really play a part in this because nothing's being multiplied by 3. I can't change 3 to 0. It doesn't make a difference. Okay? So now I have x plus 1 and x plus 4, so my answers are, again, fairly obvious. -1, -4. So x can equal -1, or x can equal -4, or it could be both. Okay? Again, just to show you what it looks like on a graph, -1 and 4 on this parabola would be right here and right here. -1 comma 4, or sorry, -1 comma 0 and -4 comma 0 as well. They will, a parabola will always open upwards or downwards. Somebody said something up there. If it asks you to answer it, it's probably just asking for x. If it says write down the intercepts, that will always be in a coordinate pair. Okay. If it's opening downwards, there will be a negative leading coefficient. If it's opening upward, it will be positive. Okay. Any more questions there before I move on? Okay. Next example, and we need to flip the page to something that is cubed, preferably. Okay, example 5 has something cubed. Let me see if I can find it better. Okay, example 5 is going to have to work. Yes. 2p to the third, or cubed, plus 5p squared minus 3p equals 0. So step 1. Is this in a form where I can factor out the 3's using the formula open parenthesis, a plus b, close parenthesis, open new parenthesis, a squared? It's not, right? So what do you notice about p?
They all have p.
They all have a p. So what can I do with p? Take a p out. So p, open parentheses, 2p squared plus 5p minus 3. Anything else I can pull out of that before I move on? No, there's, okay. Now I can go ahead and factor. I'm going to use the AC method. I get a -6 when I multiply a and c together. So that means I have factors of 6 that when subtracted will give me 5. What are they? Be a 6 and 1, right? So p, open parentheses, I'm going to have 2 of them. It's going to equal to 0. I'll start filling in my blanks. I have 6x and I have 1x. Which one of these is going to be subtracted? Or negative, sorry. The 1, right? So it's going to be a -x on the bottom. 2 is prime, so life is made easy there. 2p and 1p. And I ask myself, can I turn a 2p to a negative x? Sorry, negative p. Huh. So, no, I can't. So, but I can turn it to a 6. So, 2 times what gives me 6? Positive 3. And what times p gives me a negative p? Negative 1. So here it is. This is my 3, I repeat, 3 factors. I have a p, I have a 2p minus 1, and I have a p plus 3. So p equals 0, 2p minus 1 equals 0, and p plus 3 equals 0. So this one's easy. It's already solved for itself, right? P equals 0. But you have to set each of your factors equal to 0. That last example where we had a 3 out front, if you set a 3 equal to 0, it just doesn't make sense. That's why we didn't do that, okay? So going back to our example where there's a variable, p could possibly equal 0 there. And then I would just finish solving this one. Add 1, divide by 2, we'd get positive 1/2, right? So, p can equal 1/2, it can equal 0, and then here it can equal negative 3. So those are my 3 options. I would run that through whatever problem they give me and see which one of those works best.
How do you graph it?
If this one was asking for a graph, cubes look like, I'm going to draw a generic cubic form right here. It looks like this normally. Okay, there is a small possibility that the graph of this one would look like, let's see, okay, it has to go through 0, it has to go through 1/2, and it has to go through negative 3. So if I was to guess, it would have to, so it's positive, go something to the effect of that. That's a guess on the graph. If I was really going to do it, I'd just plug it in my calculator or something. Or plug in some test points and see the direction that my graph goes. Okay, but regardless, your x-intercepts are, again, where they cross the x-axis at 0, 0, 1/2, comma 0, and negative 3, comma 0. Okay? Questions there? When you get to ones that are like true cubics, and I'm not seeing an example here, where you would use this formula, a plus b, a squared minus a times b plus b squared, you do the same thing there, okay? You would set this equal to 0, and then you would set this equal to 0. If this is not factorable, setting it equal to 0 will probably not help you, okay? So they won't give you problems like that. If they do, call me over there and we'll work through it. Chances are you just missed something that you could use to solve it, okay? Questions, comments, concerns? Okay, if you get to anything on your lesson that you think we need to add to our notes, let me know. Okay, number 19 from the practice set was requested. That's on page 358, right?
Yeah, that was on the very first problem on my lesson. I had no idea which.
X squared plus 5x
Yeah.
equals 0. Okay, so here's that problem. What, 5x, right? What can I factor out of both of those terms, x squared and 5x? I can factor out an x. So x pulled from x leaves an x pulled from 5x leaves a 5. And it equals 0. And I'd set each of those factors equal 0. So x equals 0 and x plus 5 equals 0. So x must equal negative 5 and 0.
Okay,
Good?